So here we go. It says, list at least 7 things you can conclude about the following figure. Well, we might not get to 7, but let's start concluding some things about this figure. First of all, this angle right here is 52 degrees. Okay, that's 52 degrees. So what's AB out here? 52. Now, ATC is a diameter, right? So how far is it around this side of AC? A diameter cuts off half of a circle. What's half of a circle? How many degrees? 180 degrees. Okay. So what's left for BC? How many degrees is left for BC? Where have you been, Mr. Hahn? What's left for BC? 128. So how big is this angle right here and here? 128. Now this is where we learn about inscribed angles. This and this are congruent because they're both radiuses of the circle, radii. Okay? And this is also a radius. So it makes what type of a triangle out of BTC? What type of a triangle is this called? Isosceles. You guys are smart. Isosceles triangle. So if it's an isosceles triangle, we use 128 degrees here. How much is left for each of these? Well, what's 180 minus 128? 52. Okay? Divided by 2, because there's 2 angles that share the 52. 26. So this is 26 and this is 26. Now, this is 26. This is 52. How do they compare? 26 is what of 52? Half of 52. Okay? So an inscribed angle. The inscribed angle equals 1/2 the intercepted arc. And shows you what an intercepted arc is. An arc cut off by the angle. So an inscribed angle equals 1/2 the intercepted arc. So the definition of an inscribed angle is an angle that has its vertex on the circle and the sides are chords of the circle. So its vertex has to be on the circle to be an inscribed angle. So an inscribed angle has a vertex on the circle and its sides are chords of the circle. An intercepted arc is an arc cut off by the inscribed angle and lies to the interior of the 2 chords. So you have an intercepted arc and you have an inscribed angle. You need to know both of them, okay, what they are. Vocab test will be next week. Or no. Yeah, I think it'll be next week. Okay. Everybody got these definitions written down? Almost, not quite. Was that the last vocab word of the sheet? There's one more. Secant. Oh, yeah. Secant. A secant line. All right. Here we go. All right. So, DG Arc DG is 45.6 degrees. How big is angle E? Well, what do you do to this arc? Do you multiply by 2 or divide by 2 to find the angle? Divide by 2. 45.6 divided by 2 is 22.8 degrees. That's what angle E is. So then what would angle F be? The same thing. Why is it the same thing? Because it cuts off the same arc. Two angles can cut off the same arc. You can even have more than two angles. All right. Now, this is 180 degrees over here because it's part of a diameter, right? Cut off by a diameter. How big does this angle look over here? That's this one on this side, to the right side. EH, and then over here. Let's call this M. EHM. How big is EHM? Does that look like? That looks like 90 degrees. So if you have a tangent to a circle and a diameter, okay, it makes a 90-degree angle. So let's say this is like 70 degrees right here, which would make 110 here. Okay, if this was 70, how big would this angle be? Not 70. It's half the intercepted arc, so it's 35 degrees. Well, if this is a 90 degree, a straight line makes 180 degrees, right? So if this is 90, we have 90 left for this. So this would have to be 55 degrees, right? So how does a tangent line and a chord compare to an intercepted arc? Well, the angle formed by a tangent line and a chord is half the intercepted arc. So it acts just like an inscribed circle. When you have a tangent line and a chord that makes a 120-degree arc, then the angle is 60 degrees. It is half. Okay? So BD is tangent to circle. BDE is 65 degrees right here. How big is this arc over here? How big is the arc DFE? How big is DFE over here? What's 65 times 2? 130 degrees. 130 degrees. The arc is twice the angle. The angle is half the arc. Okay? All right. If this is 30 degrees, how big is this angle right here? It's 15 degrees. Okay? It's 15 degrees. All right, and we won't worry about that question so much because I don't like it very much. So, the angle's half the arc is twice the angle. That's what we need to know from this section. I will put out the assignment here in a couple minutes, and then you can get